Why does security always feel like an afterthought, right? If you're a developer, you know this pain all too well. You spend weeks, maybe even months, meticulously writing code, optimizing features, getting everything perfectly ready for a big release. You can literally see the finish line. And then, bam, your code gets handed over to the security team for an audit, and everything just grinds to a halt. They find vulnerabilities, and suddenly your work gets kicked all the way back to square one. It's incredibly frustrating, it totally kills your momentum, and honestly, it makes security feel like the enemy of progress. But it absolutely doesn't have to be this way.
Okay, let's dive into this. Here is our roadmap for the explainer today. We'll be hitting the traditional security bottleneck, the shift-left philosophy, automating the CICD pipeline, real-world DevSecOps tools, bridging dev and sec teams, and we'll wrap up with the engineering benefits. Let's jump in. Starting off with Section 1, the traditional security bottleneck. To figure out how to fix the future, we kind of have to look honestly at the past. Traditional development models basically set teams up for failure by keeping security totally isolated from the actual creation process. Think about the old workflow. Development happens in a silo, testing happens, and then right at the very end, literally right before production, the security team finally steps in. It's kind of like building a car, painting it, and then asking someone to check if the engine actually has oil. If there's a problem, developers are forced to context switch back to code they wrote weeks ago. It's just incredibly inefficient. But with DevSecOps, security isn't this final hurdle you have to jump over. It's a continuous thread woven into every single stage of the process, right from day one.
And the reason that traditional model is so fundamentally broken today is because of how we actually build modern applications. We aren't just writing simple, monolithic blocks of code anymore. Modern apps are complex ecosystems. They rely heavily on microservices, countless third-party components, open-source libraries, APIs, the whole shebang. Your application is pulling in all sorts of dependencies, it's managing sensitive secrets, generating massive amounts of metadata, which vastly increases your attack surface. If you wait until the very end of the cycle to check all of these interconnected, moving parts for vulnerabilities, you're basically looking at a recipe for absolute disaster. There's just way too much to manually verify at the last second.
Which brings us to Section 2, the shift-left philosophy. This is the core concept that solves our bottleneck problem. Once you grasp this, the entire DevSecOps movement makes perfect sense. So what does it actually mean to shift left? Well, if you picture your software development lifecycle as a timeline reading from left to right, starting with planning and coding on the left all the way to deploying and monitoring on the right, shift-left security is the practice of moving your security testing to the earliest possible stages on that timeline. Think about it like building a house. You wouldn't wait until the house is completely built, painted, and furnished to inspect the electrical wiring and plumbing inside the walls, right? Because if you find a problem then, you have to tear down the drywall. It's expensive, it's time-consuming. Instead, you inspect the wiring while the walls are still open. Shifting left is exactly that, inspecting the code while it's still being built.
But shifting left is much more than just a technical adjustment, you know? It is a massive cultural shift. It means security becomes everyone's responsibility, not just the security teams. In a true DevSecOps environment, developers are empowered with the knowledge and the tools to own the safety of their code. You aren't just throwing your work over a wall and crossing your fingers that it passes an audit later. You're actively ensuring its security as you write it. It totally democratizes security and embeds it right into the engineering DNA of a company.
All right, Section 3, automating the CI/CD pipeline.
Because let's be real, manual checks slow things down. And that's exactly where automating your CI/CD pipeline comes in. Think of the pipeline as the automated assembly line for your code. As your application comes to life, security checks are injected automatically at every single stage. When a developer commits code, automated build scans kick off immediately. That's followed by continuous testing, analyzing dependencies, checking container images, verifying configurations, all leading up to a secure deployment. And the real beauty here is that these automated checks are happening in the background. They do not slow the developer down at all. The machine is doing the heavy lifting, hunting for vulnerabilities, while the developer keeps their momentum going.
Let's move to and see how this builds into an actual day-to-day workflow for an engineer. Step 1, you commit and push your code. Step 2, that action acts as an automated trigger in your CI/CD pipeline. Step 3, an instant scan is performed on that specific chunk of new code. And Step 4, immediate developer feedback. Instead of waiting 3 weeks for a security team to email you a massive spreadsheet of errors, you get an automated comment directly on your pull request within minutes. It tells you exactly what line of code has a vulnerability, and honestly, often tells you exactly how to fix it. The context is fresh in your mind, so fixing it takes seconds, not hours.
Moving on to Section 4, Real-World DevSecOps Tools. Now, to make this automated magic actually happen, you need a specific tech stack. And the modern security stack is just incredibly powerful. You've got containerization and orchestration platforms like Docker and Kubernetes, which let you package and deploy apps super consistently. But you absolutely must secure those containers. That's where automation servers like Jenkins or GitHub Actions come into play. They run those pipelines we just talked about. And integrated directly into those pipelines are tools like SonarQube, performing continuous inspection of code quality and security, just hunting down those vulnerabilities in real time. These tools integrate seamlessly to protect your applications from the inside out.
And comparing the old way to the new way, it's literally night and day. Manual security audits are agonizingly slow, highly prone to human error, and they scale incredibly poorly. A human simply cannot check every single open-source library dependency manually. It's impossible. On the flip side, automated scans powered by tools like SonarQube and Jenkins are lightning fast. They are entirely consistent, and they run every single time code is pushed. Automation takes all those repetitive, high-volume tasks off the human plate, ensuring absolutely nothing slips through the cracks.
Section 5. Bridging Dev and Sec Teams.
Now, what's really interesting about this is that tooling is only half the battle. Did you know there is a massive scale mismatch in your typical tech company? Roughly 5% of staff are security professionals compared to 95% developers. The math simply does not lie here. It is physically impossible for that tiny sliver of security experts to manually review, audit, and secure the output of that massive development team if they're acting as a gatekeeper at the very end of the process. This proves exactly why security has to be automated and why developers must be empowered to handle the first lines of defense. The traditional model is literally a mathematical impossibility in a fast-paced, agile environment.
By integrating these tools and shifting left, we've fundamentally changed the relationship between these two teams. In traditional silos, you've got conflicting goals. Devs want to release fast. Security wants to block anything risky. Naturally, this breeds a pretty toxic blame culture. But with DevSecOps, you finally have shared goals. Security provides the automated tools and guidelines, and developers use them to write safe code right from the start. It takes what used to be an adversarial relationship and turns it into a wonderfully collaborative one. Everyone is finally on the exact same page, aiming for fast but incredibly secure releases. And finally, Section 6, the engineering benefits.
Let's talk about the tangible payoffs here. The cost, both in literal dollars and in engineering hours, to fix a vulnerability at the commit stage is practically negligible. It's essentially zero. The developer gets a ping, changes a line of code in a minute, and moves on. But if that exact same bug makes it all the way into the production stage, the cost absolutely skyrockets. We're talking emergency patches, potential downtime, massive context switching for the dev team, and possibly severe brand damage if it's exploited. Shifting left is the ultimate cost-saving measure, because you catch bugs when they are cheapest and easiest to squash.
And the efficiency gains are staggering. Organizations that successfully implement DevSecOps routinely see an 80% faster bug resolution time. 80%! Think about how much friction that removes from your day. That instant automated feedback loop creates a vastly smoother, happier workflow for engineers. You spend way less time hunting down old bugs from weeks ago and way more time actually innovating and building exciting new features.
So, the crucial point is this. Security is no longer just an audit. It is a foundational part of the engineering process. DevSecOps empowers you to build faster and safer simultaneously. I want to leave you with this final thought. Look at the software you're building right now. How are you going to shift security left in your next project? How can you implement that automated feedback loop today so you stop treating security as an afterthought and start treating it as a core feature of your code? Thank you so much for joining me on this explainer, and I challenge you to take these principles and start building more securely tomorrow.